Good morning, everyone. My name is Jason Arms, and I'm with First RGV and RGV STEM, and we're excited to be here today with Patriot Engineering. They're going to talk to us about all the great things associated with Fusion 360. And this is going to be a three-part series, and today is going to cover how to get started and some basic functionality of Fusion 360. And so don't forget to subscribe and follow us on social media as First RGV on Facebook, Instagram, Twitter, and of course, join the Discord by joining our Discord server. And that link is in the bio on most of our social media accounts. So with that, I'd like to turn it over to the amazing coaches of the Patriot Engineering program with Mission Consolidated Independent School District, Ms. Veronica Bergoa, that has a long history of FIRST Robotics, long before First RGV was around, and Mr. Jose Sanchez, also with Mission CISD and has a history now of several years with FIRST, and we are excited that they're part of our family. And Ms. Bergoa, take it away.
Oh, good morning, everybody. I'm very happy that you're here, and I would like to welcome to an awesome training. And also, I would like for Mr. Sanchez to give you a few words before we start and we take time away from our wonderful presenter. It's on you, Mr. Sanchez, our head coach.
No problem. Hi, good morning, everyone. My name is Mr. Sanchez. I'm one of the coaches at Patriot Engineering. Like Mr. Arms has said, I've been competing in FIRST for a couple of years now. Great organization. First RGV is doing a good job in growing it here in the Valley. We're excited for everybody that's here. We're excited to have one of our students present. It's a great opportunity to network with each other and help each other out here in the Valley, especially during these times where we do need to get in touch with one another virtually so that together we can overcome the challenges that we're facing. We're happy that one of our students, Lucas Dovalina, is going to present. I'm going to hand it over to him right now. I know that he's got a lot to cover and he's pretty excited. Hopefully you guys can get a lot of from this presentation. You guys know if there's anything else you all need, you can always reach out to us and we're more than willing to help. Go ahead, Lucas.
Hi guys, how's it going? So I'm Lucas. I'm a senior. This is my 4th year doing robotics, specifically FIRST. I'll tell you how I learned how to CAD. It was my sophomore year and it was a few days before, well, we didn't get to make it a state, but another team did. At the time, the seniors class did. And they wanted me to CAD their robot. And this was 4 days before state and I had 0 experience of CAD. So I had to figure it out in 4 days. And so I learned the hard way. And well, I want to see if I can serve you guys and work to giving you the opposite. And that is to show you and to, prevent you from having to do what I did, how to learn. So to give you guys like a more guidance. So what is CAD? So essentially CAD is 3D modeling. Now you can realize that there's other types of 3D modeling. I mean, if you've ever used maybe Blender, the difference between maybe something like Blender and CAD is that CAD is very engineering oriented. So there's a lot of measurements and dimensions. Everything's very precise and specific. So let me show you some examples of some really cool CADs. So this here is an FTC team. I found it off of Reddit. I believe to give them credit, it's 12384, I believe. So that's a robot there. And they can make this with CAD. I'm not exactly sure if this is Fusion, but it's definitely CAD. There's this here, that's definitely Fusion. And there's also this as well. I mean, you can check that out there. That's pretty cool looking. And this as well. And so anybody can make this with Fusion. There's really not a lot of limits. So it's really, really great. So what makes Fusion different from other CADing softwares? Well, before we really get into this, I'd like to say that for any of you who do have Fusion, I recommend that you follow along because you can watch and you'll be fine, but it's better if you can follow along. That way you can actually practice it and get it engraved in your head. So let's go ahead and look at this. So in case you haven't seen it, I believe it's here on the website. And I think the link is posted here on how to download Fusion if you need to. So there you go. So check this out. So with Fusion 360 is different from other CADing softwares in the fact that it's cloud-based. So for those of you who know what that means, it's internet-based. So everything that you do and create will all be saved on the cloud. So your files, your parts, your drawings, animations, all of it is going to be saved on the cloud. There's a couple advantages to this. And one, which is fairly important, like, you know, if you lose your computer or you break it somehow and use your files, well, they'll be saved. But something that's really important is that if it's all in the cloud, that means that your entire team can access it at the same time, which is great. And so, well, how do we use it? On the top left side is this data panel with 3 little cube here. And on the left side, you have all these different projects. So these projects are all things you can work on. So for example, we're gonna be looking at tutorial, and everything that we do in tutorial is gonna stay in tutorial. Technically you could, you know, cross-section parts, but I mean, I don't recommend that. But yeah, so that's what you can do. And then if you want to share with people, this is your data. So if you want to share with people, you can click data on the top right. And then there you go. You can type in somebody's email address and then you send it and they can work on it, which is really great. So what we want to do today is we want to look at how to model stock parts. So if you have a robot that's made purely out of maybe GoBuilda, Rev, Vex, or Tetrix parts, and you want to put that together, well, I'm going to show you how to do that. And simply, there's no customization in this. It's just taking parts from the internet, taking parts that you can buy from somewhere, and just putting it together. So let's see. What I'm going to do is we're going to create the drivetrain. I want to create the drivetrain of a sister team in my school, 12697. They've got a fairly fast, and this is their previous drivetrain from last year. And so it was quite successful. So what we're going to do is we're going to actually build their drivetrain. So this is a couple pictures of it. Now, let's go look at docs. So what we're going to do here is I'm going to get these links for each part. Each of these is a link for a part, and I'm going to put them in the chat, and then you can access the links and we can do it together. That way we're not, you know, this unstable or something. So what's going to do? Let's get this first thing, this first link. It's going to take us to GoBuilda. But before I get into that, let me show you something. So let's get this Vex wheel. This is for Vex, in case you're using Vex. Let's open up this link, and I'm going to copy this link and put it in the chat. Let's see. Right. Okay, so you should get that chat, that link. And now you notice that on the bottom, you can see this is the wheels. It's for wheels of Vex. And you can click preview on each of these files and get the 3D model of it. And once if you like this and this is the one you want, then you can click download. And when you click download, it's going to download the file for you. And there's your part. So that's for Vex. And so it's the bottom. And you'll see it's all these little bars. It's under CAD files. Okay, CAD files. I'll show you another example. Let's look at Tetrix. This is a random, I think this is a pattern plate I saved. Oh, it's an angle bracket, that's right, Maxwell bracket. So, here we go. So here's a Maxwell bracket. I'm gonna send that link here, put this in the chat. Okay, so this here is an angle bracket, and you look on the bottom, we'll scroll down, and boom, there we go, downloads. So under downloads, and you can click download now, and it'll give you the file. And there we go, there's our file. And we use again for Rev. Now Rev is pretty much the same as the others. And so here's a 15mm extrusion. Also used for FTC. Scroll down to the bottom, and there we go, in big bold letters, CAD. And you see this first one. This first one is the one you want. This bottom one is the access to this complete Rev parts library. That's all the parts that Rev has. So in case you can't find your part, you can maybe look through there and find it there. But the first one's the one you want. We'll click that, for example, and it downloads our part. So I hope that makes sense. You just go to your website, you find the part that you want, you go to downloads or CAD files, or in this case CAD, and it'll give you a file and you can download it. And I mean, rarely will they not have a CAD file. They should have a CAD file for something. So let's go ahead and build that drivetrain I was talking about. And the way we're going to do that is I'm going to send now this other link, and we're going to get started. So let me, as we're building this, I'm going to walk you through how Fusion 360 really works. So here's this thing. We'll save that chat. Will you share your slides? Will you share the slides with CAD links? I'm not sure as to Simon. Yeah, we'll make links available after email. Okay. So here's this next link. This link that I'm going to send you right now is part of the drivetrain we're going to be building. So here we go. And let's go ahead and download it. So you click download. Now this GoBuilder is weird. Okay, I don't really know as to why, but every other website you check, as we just checked right now, when we download it, downloads step files. But in here, it's only letting us download zip files. So I mean, zip files allow you to compress, but it makes a little bit things more complex. So anyways, as you can see, here are our other files that we just downloaded. And this is the zip file from GoBuilder. This is the one we want. Now, if we look back at the part is a U channel and it's 12 holes, okay? So what we want to do is we want to extract this file. We're going to extract it and extract. And so here it is. Here it is right there. I'm going to double click it. And there it is. There's our file right there. Now, notice, does that say C channel? No. Does that say GoBuilder? No. And honestly, if you walk away from that from a few hours, you come back, you might forget what that is. So what I recommend is renaming it. And so this is a recommendation, a suggestion. You don't have to do it. But the way that I do it is I start really broad and then get more specific. That way, when things get like in alphabetical order, it's easy to group things together. So I'll show you, for example. So the most broad thing is that it's a GoBuilder brand. So it's a GoBuilder. And well, what is it? Well, it's a C channel. And then what is it? Well, what kind of C channel? Well, it's a 12-hole C channel. And that's it. That's like kind of the name I like to give it. So what we can do is put that back in our folder. And so there it is right there. There it is there. These are examples I showed you earlier. I'm going to get rid of these for now. Okay, so there's our file that we just exported and extracted. We renamed it GoBuilder C channel 12-hole. So what we're going to do now is, like I said, Fusion is a cloud-based service. So what I'm going to do is put everything and upload it. Okay. So how do I do that? Well, what we want to do is we want to go to our projects, and you can create a project whatever you want. So let's just say, I mean, this is your example. You can name it, your team name and your team number, whatever you want. You can create as many projects as you want, and it's just there for organization purposes. So I'm going to make up a name, tutorial 2. And so there's our project. Now, to be honest, I already uploaded all the files in advance because, to be honest, I do not trust my internet. I don't trust it. So I uploaded the files beforehand. So let's look at tutorial, the one that I already have. And what I did is that all the parts that I wanted to save, I simply created 2 separate folders. So I have all my actual files here for the drivetrains I'm going to be building, and I have the parts. So the reason I do that is that when I upload things get really messy. So I try to organize things, because the bigger your robot gets, the more parts you have, things can get chaotic quickly. So here are our parts. And these are some of the parts we're going to be uploading. So what we can do is click the big blue button, click upload, and it's just going to give us this pop-up box. So we're going to be uploading it to our project called tutorial in the folder called parts. We're going to select the files that we want. And the file we want is that C channel. So here's our C channel. And you can see that it's already listed the name, the step file. Oh, forgot to mention. The step file is sort of almost like the universal CAD format. So if there's Fusion 360, there's Autodesk Inventor, there's SolidWorks. And so how do you get parts that go from one to the other? Because each software has its own naming system and they're all separate softwares. So you can use a step file to go from in between each different software. So a step file is what we're going to use. We're going to upload that, and so there we go. So now it's uploading, and you can see I've already uploaded some beforehand, and just let it work for a bit. And you can close out of this. It's uploading the background, so I can close out of that. And you can see in the bottom left that it's still working. So it's uploading a bit. And like I said, I already have it uploaded. So it's right here for me already. So what I'm going to do now is I'm going to, so there it is. So I'm going to do now is I'm going to simply, well, let's first talk about this. How does Fusion work, for example? Well, Fusion, let's see. So Fusion is a top for assemblies. It's a top-down assembly. So in case you don't know what that means, what it means is that you make all of your parts and all of your files in that assembly. Because if you've ever used maybe Inventor or SolidWorks, it's a bottom-up assembly, meaning you create all of your parts from the bottom, you make them each separately, and then you put them together. Now, of course, each system has its advantages and disadvantages. In our next session, we'll actually cover the advantages of assemblies, of top-down assemblies, but not now. So anyways, so let's check this out. We're gonna right-click it. We're gonna right-click the part we want, and we're gonna click Insert into Current Design, okay? We're not gonna double-click it, because if you double-click it, well, let's try what happens. If you double-click it, it's just gonna open up the file. We don't want that, because that's not an assembly, that's just a single part. Let's go back to our thing, our original file, and we're gonna save this, okay? Let's call it a drivetrain. And so there's a drivetrain. What we're gonna do now is we're gonna import parts into our drivetrain assembly. So check this out, this is really important. If you can see where my mouse is, there's this little cube. That cube there means it's a component. And I said singular component, so it's just one piece. So the question is, if our robot is made out of obviously more than one piece, how do we have multiple pieces in a single assembly, a single component? Well, you have to make that component and you turn it into assembly. Well, how do you do that? You go to your part, you right click it and click Insert into Current Design. So we're gonna do that. And now notice that, if you wait for my slow computer, oh, here we go, perfect. So here's our file. Notice if you look at that component, it went from a cube to now 3 different cubes, meaning assembly. So 1 cube meant component and 3 cubes mean assembly. Now check this out. You see this highlighter right there? That's 1 cube. So this here is 1 component inside of an assembly. So on your left side, I should probably cover this. This is called the browser. And you can see and find all of your parts here. And I'm going to move this around how I please. And the top right, this is really important. On the top right, I have my view cube. Now, the view cube just lets you move things around, okay? You can move things around. You can click the front and look at the front. You can click the little button, the little turning button, and it can rotate 90 degrees. Do it again and again and again. And yeah, and this top left button is the home button. This takes you to what's called an isometric view. And it's both the front, the right, and the top view from the corner view, which is important to know. And yeah, so that's pretty simple. Now, what I recommend is if you're using a laptop, it should work just fine. But I've always preferred a mouse because a mouse lets you you're able to view things and turn things a lot more easily. So if you have a mouse, like I said, I would recommend you have a mouse. If you have this scroll button, and if you, like I said, if you don't have a mouse, I'll still show it in the laptop anyways. If you have a mouse, if you hold down the scroll button, it has a little button actually. I don't know if you knew that, but there's a button there. And if you hold it down, hold the scroll wheel button down, and then you drag, you'll see that it is able to pan and move your object from side to side, up and down, diagonally, and all different directions. Now, what happens if I want to turn it and I don't want to have to use that view cube? Because it might be a little annoying to have to always go back up and down to the view cube every time, back and forth. So the solution to that is you do the exact same thing, except you hold Shift and then you hold down the button of the scroll wheel. Hold it down and notice how my cursor turns into like a little atom looking thing. And what that means is that I can orbit it and I can move it around. So there we go. So let's go ahead and take it back to the home. And so you can see that it's giving us the option to move it around. And so the reason why this is important is because whatever position you lay your parts in, it remembers it that way. So let me show you, for example. Let's look at the front side. And so what I'm going to do is our drivetrain, if you look back at it, our drivetrain is like this. I don't know if you can tell, but these bars here are facing towards each other. And so the part that we just uploaded is this long C channel. Let's go back to Fusion and let's have it facing this. Let's make this the left side and let's make it facing to the other side. So I'm gonna get this bar here and notice how I can rotate it. So I can rotate it. So I'm gonna bring it up to 90 degrees and I'm gonna click OK. And once I click OK, then it remembers that spot. So I'm gonna click home again and notice this part is now facing the other direction. So the next step we're gonna do is we're gonna put parts together. And if we put parts together, well, you're gonna notice that things are gonna start to move. For example, I can click this and drag it, which is not really that good. It's good when you wanna move things around, but the problem is though, is that what good is it if your robot's gonna be moving around in a random plane? So the question is, how do you fix your robot into a single position? Well, the way you do that is you can ground it. So in the top left, you'll see that if I click the browser button, if I click our C channel, I'm clicking the component and now you can see that it's highlighted. What I can do is I can ground it. And when I ground it, it's gonna make everything fixed the way it is. So I'm gonna right click it and I'm gonna click ground. So you notice there's a little pin on the component. And so this means that if I try to drag it around, I can't. So for those of you that are following, you'll notice that if you try to drag it around, it's not going to move at all. And so this is important because if you're going to be using a robot and making an assembly, it's best if you have a part stuck down to it. So what we're going to be doing in this Fusion session is we're not going to be looking at how to actually, like I said, create parts. So in the top section here, we're not going to be using any of these but one, which we'll get into in a bit. These are all for making your custom parts, but like I said, all we're gonna be doing is downloading parts from the internet and putting it together. And yes, in the bottom section, so check this out. This is your design history. So Fusion, another good thing about Fusion is that it remembers what you're doing and it remembers what you've done. So if you click this little bar, you can go almost back in time to your previous designs. And you see that that pin there means our ground, and we can go before the ground, and now you should probably be able to move. And of course, we go back to the right, and there it is, grounded again. So this is really great in case you make a mistake, or there's one, like a long time ago you made a mistake, and you fix it, we can go back and edit it, which is useful. So let's go ahead and make that second C channel facing it. So what we're gonna do, go back to home. I'm gonna orbit it a little bit. Like I said, hold shift, click the scroll wheel button, and then move from side to side. So we're gonna orbit like that. And if I wanna move from left to right, we can click this wheel button and move from left to right. Oh, I almost forgot. How do you zoom in or out? Well, you can scroll with the scroll wheel. Scroll forward, you zoom out, scroll down, zoom in. Simple as that. I think it's backwards than most softwares, which is really weird. I think so. It's really weird. Let's go ahead and import our second piece. Let's go back to our data panel. And so here's our C channel. It's a 12-hole C channel. I'm going to import that. I'm going to insert into current design, not open it. Okay, you're not going to double click it, because if you double click it, it's going to open up it as a component and as a single file. So we're going to insert it into our current design, making it a little bit more of a complex assembly. So one more time, it gives me the option to be able to move it around, which I'm going to take that. So I'm going to exit this screen real quick. I'm going to pan it to the side, orbit it around, and I'm going to pull it. So it's giving me these three arrows, and I can pull it in one direction. I pull it, and it gives me the measurement, which I don't really need right now. And I'm going to turn it. I'm going to turn it 90 degrees so it's facing the other. Okay. I click front, and they're perfectly aligned. So we're going to look back at our model of a drivetrain, and check this out. So now we have our two C channels facing each other. So let's get the rest. What we're going to do is we need to have the second piece in the middle. There's a bar here connecting these two. Now this is a GoBuild C channel, and it's 11 holes. I will post the link in the chat one more time. Okay. I'm going to get this link, I'm going to copy it and I'll put it in the chat for you guys. Hold on. Okay. All right. So there we go. So let me scroll down to the bottom and we can see that we have our step file right here. So here's our step file. You download that. Right? You can open a folder, show in folder. And there it is. There's your zip file. So like I said, you can extract it. You're going to right click it, click extract, and you're going to open it up here in the same position. So we're going to extract that and notice how it creates a separate folder over here. So there's our folder. We're going to double click it, open it up. And like I said, really weird name. Let's give it a better name. So from a really broad perspective, what brand is it? We'll also go build a brand. Well, what is it? It's a C channel. And what kind of C channel? Well, it's 11 holes. There we go. Let's go ahead and put that into our main folder, our cat tutorial folder. So there it is. We're gonna go over here. We're gonna go back to our data panel. We're gonna go to data. Like I said, you have the project that you want. In this case, we chose a tutorial part. You can name it whatever you want. You have your project and you open up your folder of parts. These are not have-tos. These are just my suggestions. Like I said, making a parts folder just says, this is the folder with all of my parts, nothing else. That way you just have better organization. So you want to click upload. We're going to select our files. And so there it is. Or go below the C channel. Oh, that's 12 hole. No, sorry, 11 hole. We're going to upload that. And then it's already selected. And then we're going to upload it. And like I said, I already have it uploaded. And so here it is, it's uploading. And for us, it's right there. There it is. So to save time, like I said, I already have it uploaded. And because I don't trust my internet. So what I'm gonna do is I'm going to right click this. And I'm going to insert into current design. Right, you can't double click it. Well, you can, but it's gonna make a separate file for you. We wanna open up this file in the same folder, in the same assembly. So I'm going to get out of this and then I'm going to put these two behind. I don't know if you can see it in the, not this one, sorry, in this picture we have, but it's this singular bar in the background, one bar in the background. Okay. That's what we're going to do. So back to Fusion and we're going to put it here down at the bottom. We're going to put it right down here. So how do we do that? Well, let's go ahead and orbit. And let's look at it from the top. And I'm going to rotate it. That way it's perpendicular. There we go. And then I'm going to drag it this direction. And then I'm going to drag it to the right. Now notice, they're not the exact same size. Things aren't really created that well, but that's okay. We'll get there. So, and also notice that there's this middle button. And if you drag that, you can move it in all directions, which is also nice. You don't have to move it beforehand. It's just that Fusion remembers the positioning of your objects. I'll show you an example, right? So we click OK, and here's our part. Now, you notice that it should be facing the inside, right? But it's not. So what if we move it? If we move it, you'll notice that Fusion on the top right gives us these two new options. And these two new options are the following. One, you have capture position, and the other you have revert. So what happens if you click revert, for example? Revert, and it takes you back to the previous section. And so like I said, Fusion remembers the positioning of your object. So if you move it to the left and you click, in this case, capture, well, that means if you want to move it again and you revert, it's going to take you back to your previously captured position. So whatever position you capture, Fusion will remember that. It's not the end of the world by any means if you capture the position. It might be a little bit more useful later on down the road. So let's just say you don't want this capture position. Well, you can look on the bottom section, our design history. You can right click it and click delete. And notice, it gives us our two options back again. And if I click revert, it takes us back to original position. Now, here is, it was just it was a mistake, right? But I mean, we can still work with this. And so the case is that this here is facing down. The C channel is pointed down. We want it to be facing inside. So how do we do that? Well, what we can do is we're going to do something called a joint. Now, this is important because a joint is the main topic of focus for this session. Okay, the joint is the main focus. So what a joint does, let's just give a quick overview. A joint is simply mating different objects together. If you've ever used maybe a separate kind of CAD software, like I said, Inventor or SolidWorks, it's a little different actually, because Fusion 360 is weird, but it has a separate sort of they're called like assemblies, right? Like a constraint. They have separate types. So Fusion is the only one that uses just joints. A lot of other softwares use something called constraints, right? They have mates and flushes. We're not going to get into that. But the idea that I want to tell you is that Fusion is really different. I think it's the only software that I know of that uses only joints to assemble. If you're brand new and using joints, this will make more sense than using constraints. But if you came from a previous software and you're now using joints, it might be a little difficult. It might take a while to get used to. So essentially, a joint is when you get two pieces, two sections, and you put them together, and it automatically fixes them together. And it takes into account the X, Y, and Z plane. So what does that mean? Well, let's test it out. So like I said, we want to have this C channel facing that inside. So how can we do that? Well, we want to do first, let's just have this, let's just fix this beforehand. What I'm going to do is on our browser, we can do is highlight our part, and I'm going to delete this actually. We're going to try this again, okay? We're going to delete that, right click it, and delete. Now it's not gone forever. It's still in your data panel, but it's been deleted from your browser. It's been deleted from your assembly. So we're going to go back to this 11 hole. We're going to insert it into current design. So we're going to insert this into our current design, and then we're going to orbit it. That's an 11 hole, right? Yeah, it's 11 holes. And then we're going to look at the top, the side. We're going to bring it down here. Okay, so now we have it here. Like I said, we want to have it flipped and rotating, facing towards the others. We're going to look at it from the right side, and this little button allows us to spin it, right? So we're going to spin it and make it face right towards them with 90 degrees. So I want to open this time here for any kind of questions anybody has. So if anybody has any questions, if you're confused, speak up. Anybody?
All right, Lucas, I'm going to check the attendees here. Remember, a reminder, everyone, there are two ways to ask questions in this session. You can use the raise your hand feature, which will unmute you and you can ask your question directly, or you can just type your question in the chat. So if you have any questions, looks like we do have a question from Mason.
Let's see.
All right.
How do I access that?
Mason, apparently you are using an old version of Zoom and it will not allow me to give you permission to talk. If you would, please put your question in the chat. I'd appreciate it. If there's any other questions, please raise your hand and or place the question in the chat pane. And as a reminder, this session will be available later today on our YouTube channel, on the First RGV YouTube channel. So if you miss something, don't worry, we can definitely come back. And Sarah Martinez, this was explained earlier, but how do we import files again? I didn't understand.
Oh, yeah, no problem at all. So let's go ahead and look back at that. So we can pick from a lot of different websites. So in this case, we've been using GoBuilda. GoBuilda is a little bit different than the other ones, but Sarah, check this out. we can have our part, our 11-hole part, C channel, whatever the case is. You can pick whatever. And under downloads, there's a step file. Like I said, the step file is like the universal CAD file, sort of. And we're going to click that. And when we click that, it's going to download that for us. So we're going to open that file up. And like I said, GoBuilder is a little strange because it uses a zip file. So it compresses everything and you have to pull it out. So let's go ahead and take a look at this. We're going to right click it and we're going to extract it. So when we extract it, we're going to be unzipping this file. So let's go ahead and extract that. And when we extract it, we're going to get this new folder over here. And we're going to get this new folder. It has this weird name. This is the product number. And like I said, you're not going to know what this is. You're going to forget. So just give it a better name. And you can name it whatever you want. Go build a C channel. I'll give it my real name. Build a C channel. And then we say the 11-hole. So there we go. Now we have, we'll put this in our main folder. Just replace it. So that's our main folder. And here it is. So we downloaded a step file from the internet, from GoBuilder specifically. And what we want to do now is we have it on our computer. But like I said, Fusion is a cloud software. So Sarah, what we need to do is we need to upload it. We need to get it from our computer. We need to bring it to Fusion 360's cloud software. When we do that is we upload. So let's go back to Fusion. And so in our data panel, where we have all of our parts, you know, here's our data panel. We have our projects. So you pick whatever project you want. And like I said, it's best to categorize your materials. So parts, for example, you make a folder with parts and you can upload. So let's go ahead and upload what we just did. So we're going to select our file. And the file that we just uploaded was a GoBuilder C channel 11-hole. We're going to double click that. And it's going to ask us like, are you sure kind of thing? And we upload that. And there we go. So Sarah, does that answer your question?
All right, looks like you did a good job there, Lucas. Thank you. I guess go ahead. We've got about 18, 19 minutes left to go. Okay. So Lucas, if you want to get back into it, I'm looking to see how you can get those two pieces joined together.
All right, so how do we get these two pieces joined together? Well, what we want to do is in the real world, you can't, we're going to build this model as if it's the real world because this is robotics, this is FTC, and you want to be able to build things as they actually are, or maybe FRC. So what we want to do is have a separate part connecting the two of them. So in the drivetrain we're basing it off of, they use a 3-hole pattern plate. So in case you don't know what that is, I have a link already ready and ready to go. So this link here, and so this is the pattern plate that connects the two of them together. This, and also we should start first with the beam, the flat beam. So this is the beams being connected to the two of them. So we're gonna get this here, and we're gonna download this. We're gonna go to download, click that step file. We're gonna open the show folder. I'm gonna kind of speed run through this. All right, so I'm gonna get that, right click it, extract, extract. And there's our new folder. Take it, rename it, and it's a Go Build a Beam Flat, and it's 10-hole, I think. So there we go. We're gonna put that in our folder, and boom. So to recap really quickly, download, you extract it, you rename it, and then we're gonna upload it. So we just did the first 3 steps. And the next thing we're gonna do is upload it. So here we go. Data panel. We're already in our project, we're already in our folder of parts. We're gonna upload the part, select our file, and what do we call it? This one, Beam Flat Hole 10. And like I said, I already have it uploaded, so I'm just gonna open it up already. So close that, and it's right, where did I put it? Maybe I don't have it uploaded. I guess I don't. Okay, we'll just wait for it to finish. So what we're gonna do is, I'll tell you beforehand, we're gonna get these little beams here. We're gonna get these beams and we're gonna lay them across. And like I said, we're gonna put it together as in the real world. So we're gonna lay them across from here to here. We're gonna put them across from here to here, 1 and 2. And move this a bit over here. Experiencing a little bit of lag. Okay, we're gonna move it from this beam across here and this beam across here. So what we're gonna do is have our flat, our beam, and we're gonna insert it into our current design. And so if you don't get anything from this session, what I do want you to get is how to use joints. Joints are critical. Let's get into this. Let's move it around, and then I'll click OK. Exit out of that. So here is our piece. Now, a joint. A joint is right here under assemble. There's a lot of other options, but we're going to cover joint. So this is joint. We're going to click it, and notice there's a little J. So if I click the letter J on my keyboard, it's going to let me open it up. So I click joint. And like I said, so it gives us, remember, the continue versus capture position. We're going to capture the position we're at right now because we like how it is right now. Let's go ahead and capture position. And so what we want to do is, and yes, it makes the grounded part invisible. It'll bring it back, but it's strange. So let's go ahead and highlight. Check this out. We can highlight the different rings. So it gives me these different little points in which I can click. I can click there, there, there. So what I want to do is I want to click this centerpiece. And when I click it, it automatically hides it. Notice, once I click a part, it makes every other part visible. So what I want to do is I'm going to place that edge right at the edge of this. So I'm going to click that ring again, and notice how it automatically takes apart and it bridges it and puts it together already. All I did was click a ring of 2 different sides, put them together, and they face together. But notice, in the real world, a thing can go through something else. They have to bring it up a bit. I believe the dimensions, the correct dimensions are, oh, I'm sorry for that. Made you dizzy there. I should be right. So it's perfectly flat and flush, but it's sticking out to the side. We want it to be able to stick perpendicularly. So what we're gonna do is we're gonna rotate it 90 degrees. Rotate it 90 degrees. Right there. And we're gonna make sure it's stuck in place. So we're gonna give it a rigid. I'll cover the rest of these later in a bit. So click OK, and there we go. Now, notice, when I move this block here, this C channel is grounded, but everything else can be moved. But notice, when I move this, that beam we just placed moves with it. And if I move the beam, then the C channel moves with it. So the question becomes, if you bond or joint that flat beam with our grounded C channel, then this will become grounded too. So let's go ahead and do that. So we know that we want to have this part matched up right about there. Okay, that part matched up right about there. Oh, wow. Let's move it down. Okay, so there we go. So now we have these two roughly lined up, so it just makes it easier to visualize. Let's go ahead and look at it from underneath, or yeah, from underneath is probably better. So if we look from underneath, you can probably see that beam we just placed. So if I highlight it, there it is. So let's go ahead and look at the end hole. And what we're going to do is click escape. And notice how I get a ring here. This ring is from the beam. And whereas this is this one here. And this is the C channel. So the beam and the C channel are going to mix together. So how are we going to do that? Well, I'm going to click the joint button. I'm going to capture a position. And I'm going to find our beam, which we just have here. And I'm going to, I'm going to click that ring, okay? I'm going to click the ring, and then I'm going to zoom out a bit, orbit around, and notice how I can click this ring now. I click that ring, and boom. See that? And now, see how it kind of animated right there? So there it moves in position. I click OK, and there we go. Now the two are jointed together. So check this out. This C channel was grounded in place, and now that beam was attached to that that C channel, which is grounded. We attach that beam to the other C channel right here. This is really cool because now whenever I try to move this, it's stuck in place. And it's firmly stuck in place. Let's go ahead. I'm running out of time. So what I want to do is just do a little quick speed run, and I want to try some other joints, some other things. So let's go ahead and look at placing a quick pattern plate. So what I'm going to do is go here. I'm going to show you guys the other link. Did I not put the link in the group chat, in the chat? I didn't put the link in the chat. I'm really sorry about that. Totally forgot.
And while you're posting that link, we do have a question from Mason. It says, can you add a variety of pieces from the drivetrain all at once, or does it have to be one at a time?
Okay, so that's a good question. Did I put in the link? No, I didn't. Hold on. Here we go. So the answer to that question is the following. Not really. What you can do is you can import a part. Let's just say this, for example. You can import that part. Wait for it to load. And what I can do is I can place it wherever I want. But in order to do that, I have to copy and paste it essentially. And that's how you can do that. So you have to go one by one. And if you want multiple pieces, you have to maybe copy and paste them, or maybe practically just copy them. So you would, in that case, you click move/copy, and then you would click this part. And then at the bottom right, click create copy. And then you can see that it gives me a second object. That's how you would do that. Does that answer your question, Mason?
All right. And we have another question if you want to go ahead and take it now. Would I be able to still move even though it's grounded? Would I have to unground the whole assembly?
Okay, well, I'm not exactly sure what you mean by that, Andre, but I will tell you this. You can move your entire, your view. You can move your entire view around even though it's grounded, but your robot will be stuck in place. However, using something like the joints, you can still have stuff move around a bit. Look back at your question. Can you, 1 second, Gabriel. So you would want to keep most of your assembly, once you ground one piece and you attach multiple pieces to your ground, your assembly will become mostly grounded, which is what you want. Because like I said, if it's not grounded, things get a little bit chaotic. I hope that answered your question, Andre. Let me know if it doesn't. Gabriel, can you catch some chains? Oh, chains are very complex to do. Technically you can. Highly don't recommend it. Not right now. Chains are very, very complex to do. Well, technically they're not really, but if you want to have them move, you want to have a chain move in real time, that would be kind of complicated. You could technically catch some chain, but we're not going to get there yet. That's later on down the road.
Maybe that's something you can cover in one of the more advanced trainings, Lucas.
Yeah. Okay. Let's see. I'm going to cover something really quickly because we don't have a lot of time. And the last thing is using a joint to have something to move. So this is not really the drive, but let's sort of. I'm going to get a axle, 100mm axle. Copy that link. And I'm going to put it in the chat. You guys can go ahead and download it on your own, but I already have it imported. So I'm just going to skip right ahead. So here's our axle, our 100mm axle. We're going to insert that into our current design. Okay, great. So here's our axle. I'm going to pull it to the side. Okay. Now, like I said, this is not very realistic. This is the last thing we're going to cover here, but I just want to show you guys how to have something move. So for example, this is a cylindrical surface. Now I can get a joint and we can click the face of that axle. And then we can click the center ring of this joint. And notice when I click it, it gets into place and it's stuck in place with the rigid. Now, we're running out of time, sadly, but I wanted to cover is the motion. So we've been covering rigid this whole time. Rigid means it's stuck in place. Now check this out. If I do a revolute, notice how it starts spinning. Because this is super useful so that once you click Revolute, that means it can spin as much as it likes. So if you want to start to CAD out a wheel or a gear, or like you said, maybe a chain, you can have something spin using a Revolute joint, which is useful. Whenever you have something to be rotating, use a Revolute joint. Very important. So a rigid is when it's stuck in place. And notice that. It's stuck in place, and I'll animate that again. It jitters a bit. When it's a Revolute, it spins. Okay? And a slider, if you can guess, just slides back and forth. You can change which axis it slides on. You can maybe do the Y. That's not very realistic, but you could. You can do the X-axis. Again, not realistic, but the Z. But notice, this is really interesting, is that Fusion picked automatically this axis. Fusion is a very intelligent software, as most CAD systems are. So that's a slider. The next one we have is cylindrical. What this does is that it does a combination of sliding and revolutes. So we're gonna click that, and notice how it revolves and slides back and forth. Next one is a pin slot, and so it moves up and down, right? And it revolves as it's doing that. Planar is as it moves on a plane, right? Two different planes. And the last one is a ball. So like a ball and socket kind of joint. So it's able to move in all different directions. We'll click Revolute, and you see that it's stuck in place. Oh, sorry, that's spinning around. So yeah, that's that. And yes, so like I said, if you ever make a mistake in your joints, then you can right click here, and you can click each of these joints. So far we made 3 joints. Our rigid one, which shows us to be this blue highlighted joint right there. It's a rigid joint, and it's a beam between our second C channel and this flat beam. Our other rigid is between our grounded C channel and this flat beam. And then our last joint is a Revolute joint, and it's this axis spinning around. So I know there wasn't a lot of time to cover joints. I hope I helped somehow. If you have questions, shoot them in the chat and let me know. Let's see. They come, oh, I thought that was just me. They come one by one, right?
I think that's in reference to the chain links, Lucas.
Oh, okay. I'm sorry. I didn't see that. Let's see. Jason, we have 15 minutes.
Yeah, we still have 15 minutes because we've got kind of a late start. So, Lucas,
Okay.
if there's anything that you want to wrap up on, if there's any questions, this is time that we'll use to clean up any pending questions. But it's important for everybody to know that we will be getting more in detail in session 2. So we do encourage you to visit the first RGV website, click on events, and go ahead and register for session number 2 so that we can continue this discussion and get a little deeper. So if there's any additional questions, please go ahead and put them in the chat. And Lucas, if you'll just work towards a stopping point.
Yeah. I think for right now, we'll just cover some questions so we have time for that. So who's got questions? Speak now or forever hold your peace.
And as a reminder, this will be on YouTube later today. So if you've missed any of the links, if you were not clear on something, you can always go back and revisit it later today.
All right, well, I'm gonna just keep working on stuff, and someone interrupt me with a question. So instead of just me waiting, just like I said, shoot me with that question. I'm ready. So to review one more time, right? A joint, you can get 2 pieces and put them together. So a rigid joint has everything stick and stuck in place. Okay. A revolute is able to spin. A slider can slide back and forth. And a cylindrical, as you saw, we'll animate all these as I'm talking. But like I said, we can right click each of our joints. We can edit. So in case you make a mistake, well, we're gonna take a look at it. We can look at it on the top right, click motion. And what we can do is click that animate button, and you can watch as it spins around. We can pick another example. Let's try, let me think. Let's try putting a gear onto this. Like I said, for the sake of time, I already have it imported, so I'm just going to import it. I'll put the link in the chat for that? It's the gear. That gear. Copy that. Here we go. If you added a few pieces for the drivetrain that you didn't need, would you just need to simply delete them, or is there more to that? If you had a few pieces of the drivetrain that you didn't need. Okay, well, yeah. Oh, yeah, it's super easy. Yeah, let's look at that really quickly. Check this out. What happens? Here's an interesting question. What happens if I do this? I highlight, right? I just drag and I highlight some stuff. For example, these pieces. My computer is loading. And it's frozen. There we go. So what happens if I click the button delete on my keyboard? Delete. And it should. Well, to answer your question, while this is working, yes, you can just simply delete them. There's no big process to that. Maybe a little bit, like I said, all of your parts are stored on the left side on the data panel. Yeah, it's frozen. All the parts are stored on the left side in your data panel. And yeah, it's just as easy as that. Did that answer your question? Who asked it? Did that answer your question, Mason?
I know if there's one thing, Lucas, that you might want to clarify. I know these are all stock parts, right?
Mm-hmm.
And I know you're not going to go into this until later on, but okay, so but what if a student encounters a custom part, something that there is no step file for? Let's say acrylic. A lot of teams use acrylic on their robots. What would they do in that case to get that part onto their CAD design?
Well, that's what I want to cover in the next section, but I can give you a quick overview of that.
Yeah, just a quick, like, what would they have to do for those?
Yeah.
Just so that they kind of have a general idea already.
Yeah, no problem. So the way that works is that what you would do for that, let's go ahead and just open up a separate file. We can do this actually super quickly. What I can do is create a sketch. So we start with 2D. This is really quick. We start with 2D, and let's just say your acrylic piece. Look from the top, like I said, a sketch, like a drawing. You can make a sketch of a square, for example. You make your dimensions, you click OK as your finish. And here's your two-dimensional sketch, your two-dimensional acrylic, Lexan, plexiglass, whatever it may be. And you're going to extrude that. So I'm going to click that face, sorry. And then I'm going to click it and then pull it. It allows me to have a piece. So an acrylic piece might be maybe 2 millimeters thick or something. I click OK, and that would be the case. Now, to answer the question, how would you put it together? Well, let's look back over here in our drivetrain. We want to make a sketch, for example. We could just simply get a plane like this. We could look at maybe this side, it can be anywhere. Make a square of some kind. We can click OK for that sketch. We'll extrude it. And like I said, I'm going to do this quickly because this is what we'll cover in the next section. I'm going to pull it up a bit. Click OK. And what I would do is I would make a joint between the two of them. So if I click joint, oh shoot, notice how, if I click joint, I can click maybe like maybe this ring, for example. And then notice how I can actually click somewhere on this piece. So I can maybe click this, for example. This is totally random. I wouldn't assume that you would use this as, oh, this is important. Look at this. Fusion decided that a Revolute joint would be the best. Is that true in reality? It's not true. And it also decided to put it sticking in the middle, which is not going to work either. You're going to have to pull it up. Oh, sorry, other direction. Pull it down. And you'd have to make it a rigid. Make it a rigid. And the last thing that I would say is that it's not fully touching. So let's go back to position, and we can pick it up. It's too far. Let's say, I don't know, -25. We click OK, and there we go. That's how, oh wow, I had a problem there. Let's see, there was an issue with, I'm not sure what the issue was, but the idea is that you would get a piece and you join it together. So essentially, when you make a piece like a custom part, for example, you could just flap it down with the joint. So who has questions? I think we'll wrap it up here. We're out of time here, but
One last thing, I don't know if you want to throw it out there. Is there, from personal experience, is there any parts out there that do not have it's very difficult to find a step file for? Like, is there a step file for, let's say, surgical tubing? Because I know a lot of teams use surgical tubing.
I'm not sure about surgical tubing. There is cases in which you can't find CAD files. It's not often. It's kind of a rare situation. But in that case, if you do come into a situation like that, the best bet would be you would find someone else that made it online. You can go to, I should probably mention this.
Yes.
There's another website called GrabCAD. GrabCAD's a really good website. I think you have to create an account for it. And what you can do is you can actually put in the chat here. GrabCAD's website, what you can do is that you can find people that upload their own step files and their own CAD files on the internet, and you can find them through that. So if you came out of that, then you can just hopefully find someone who already made it. And if you can't find that, you'd have to make your own custom part for that. Did that answer the question?
Yeah, I think that's great, Lucas. I do appreciate. Wow, that was a lot. And with the plexi at the end, we're definitely going to need to get back into that in session number 2. I think that's amazing. And this was my first experience with Fusion 360. I think it's a great program. And to remind everyone, if you do not already have it, go to our website and click on today's event, or click on part 2's event and scroll down towards the bottom of the description, and you will see how to download it. There's a step-by-step guide that was prepared by South Texas College, one of our partners, on how to get it. It is free for 1 year for students. So please make sure you take care of it. And grab it. And if you have run into any licensing problems, please make sure that you reach out to their help desk and let them know that you are part of the First RGV family, and they will gladly be able to get you licensed up and good to go for a year. So with that, I'd like to thank Lucas, Mr. Sanchez, and Mr. Bergoa from Patriot Engineering with Mission CISD, one of our participants in the First Tech Challenge and First Robotics competition programs here in the Rio Grande Valley. We will have session 2 coming up. It's already on our website. You as soon as you disconnect from here, you can go ahead and register to reserve your slot on the second session. And we hope to see you soon. Is there anything you'd like to add, Ms. Bergoa or Mr. Sanchez? You're muted, ma'am.
Yes, I'm sorry. First of all, I would like to say thank you to First RGV, especially you, Mr. Jason Arms, for allowing us to be able to reach the community and the community of science, technology, engineering, and all of this. We are all together a community, and our purpose is to find ways to communicate and to make connections to each one of us in this area, and not on this area, and every part that is an opportunity, we would like to reach that. But I have something that I would like to see if it will be possible.
Okay.
Lucas, it will be possible to create a chat room from here until next session. Instead of student has questions about or challenges about doing something, that they can reach out the C19 12447.
Oh.
And I would like to offer that. So for next session, the students are already cut up all of this part and they practice. And if they have a challenge, they can reach up to you, of course, after hours. I don't want for you to get interrupted during class time. Mm-hmm. You can check the chat in the afternoon, something like that we can offer to our community.
Yeah, there's a great opportunity for everyone to join us on our Discord. If you go to firstrgv.me/Discord, we will create a channel specifically for this class. So if you go to our Discord channel, we will get Lucas to be the moderator of that channel. And so if you have any questions, we are going to be doing some design challenges later on as we get closer to the start of our season in January. So we will have a Fusion 360 chat, and we will get Lucas set up as a moderator. So please stop by our Discord. It's free. Just download the app. And the invitation for that is firstrgv.me/Discord. And join us on Discord. And we also host gaming nights. Like last night, we were playing Among Us on the Discord. So we encourage everyone to join us. It was a sus event for those that play Among Us. So thank you, everyone. Patriot Engineering, you guys are amazing. With that, I'd like to close us out. And oh, go ahead, Lucas. Go ahead, sir.
One last thing. If anybody needs to reach out to me, you can reach out to our team, and we have an Instagram account. In the chat, there's our Instagram account, Xenon12447. Search it up on Instagram. If you have any questions, just reach out to us.
All right, sounds good. Well, thank you, everyone, and enjoy the rest of your Saturday, and we'll see you back for session number 2 with Patriot Engineering. Thank you.